If you're pregnant and drinking green tea, you need to stop right now. Not because of the caffeine, but because of something far more dangerous that your doctor probably never mentioned. I'm Dr. Ben Lynch, and I've spent 15 years studying how nutrients interact with your genes. Specifically, how certain foods and drinks can block the vitamins your baby's brain desperately needs. And what I'm about to show you connects 3 peer-reviewed mechanisms that most pregnancy doctors have never seen in the same place. This isn't opinion. It is literally published science, and it explains why women think that they're doing everything right, such as taking their prenatal vitamins, eating clean foods, drinking green tea for antioxidants, are unknowingly sabotaging the one nutrient their baby's brain desperately needs the most: folate. Here's why you need to put down that green tea or matcha latte, and here's what's happening inside your body when you don't. Chapter 1. What is EGCG and why does it matter? Green tea contains a compound called EGCG. That's epigalactocatechin gallate. It's responsible for most of the green tea's health benefits: the antioxidants, the metabolism boost, even the potential cancer-fighting effects. Researchers have described EGC as a very mild form of methotrexate. What is methotrexate? It's a chemotherapy drug specifically designed to kill rapidly growing cells. Now, when you're not pregnant, killing rapidly growing cells is a good thing. It helps keep any rogue cancer cells in check. But when you're pregnant, your body is growing a baby, and that is a massive amount of rapidly growing cells. The very mechanism that EGCG uses to stop the growth of unwanted cancer cells is also the same mechanism that can affect the growth of your baby's precious new cells. How does EGCG keep rapidly dividing cells in check? By destroying folate in 3 different ways. Why is folate destruction terrible during pregnancy? Folate is critical for neural tube closure. This process forms your baby's brain and spinal cord. If folate levels are too low, you're looking at neural tube defects like spina bifida, or congenital heart defects, the most common birth defects in humans. So if you're trying to conceive or already pregnant, every cup of green tea is actively working against the one vitamin your baby needs the most. Now let me show you exactly how this happens. And let's start with mechanism number 1. Chapter 2. Mechanism number 1, blocking absorption in the gut. So how exactly does EGCG block folate? It starts in your gut. Every time you take a prenatal vitamin or eat a folate-rich meal, your body has to absorb that folate through your intestinal wall and get it into your bloodstream. And there's a very specific doorway that folate uses to get through, and EGCG is blocking it. Your small intestine has a specialized folate transporter called PCFT. That stands for proton-coupled folate transporter. Think of PCFT as a revolving door that lets folate molecules pass through your digestive tract into your bloodstream, one folate compound at a time. Here's the problem. EGCG, natural folate, and unnatural folic acid all use the exact same transporter. They're literally all competing for the same door. And here's what you need to know right now. When you drink green tea with a folate-rich meal or taking a prenatal supplement, EGCG molecules bind to PCFT and physically block folate from getting through. While EGCG is occupying the transporter, your folate has nowhere to go. It just passes through your digestive tract and gets excreted, unused, wasted. In a human study, researchers had people take folic acid supplements while drinking green tea. The green tea interfered with folate absorption so severely that the amount that actually made it into the bloodstream dropped by up to 40%. 40%. Think about that. You're taking your prenatal vitamin. You think you're protecting your baby, but if you're drinking green tea with it, or even within a half an hour to an hour of taking it, nearly half of that folate never makes it into your bloodstream. And here's what makes this even worse. Even after your EGCG breaks down in your gut, its degradation product continues blocking the same transporter for 30 minutes or more. Now here's the part that really concerns me. PCFT isn't just in your gut. It also transports folate across the blood-brain barrier into your baby's developing brain. So EGCG could be blocking folate delivery at both places, not just stopping it from entering your body, but also stopping it from reaching your baby's brain where it's needed the most. Now, separating your green tea from your prenatal vitamin by 30 to 60 minutes can help reduce this gut level blocking, but timing only solves mechanism number 1, and there are 2 other ways that EGCG attacks your folate, and timing doesn't protect you from these 2. Chapter number 3, mechanism number 2, disabling the activation enzyme. Mechanism 1 blocks folate from getting absorbed in your gut, but mechanism 2 is even more sinister. When you're growing a baby, you need to generate a steady supply of strong, robust DNA for every cell in your baby's body. You may remember back from high school biology that DNA is made up of 4 building blocks known as nucleotide bases, A, T, C, and G. And here's something amazing. Folate is essential for making 3 out of 4 of your nucleotide bases. Folate actually helps to make A, G, and T. But here's what you need to know about EGCG. It disrupts the production of the T nucleotide. And the T nucleotide is vitally important for making strong, robust DNA. In fact, this is the very mechanism that gives EGCG its cancer-fighting properties. If there isn't enough T, then the body makes fragile DNA and cells die. This helps to slow down rapidly generating cancer cells. When you have cancer, killing the rapidly growing cells is a good thing. When you're trying to grow a baby, killing its precious new cells is not what you want. Obviously, you're not getting chemotherapy doses from a cup of green tea, but the mechanism is identical. DHFR inhibition. But how does EGCG disrupt production of the T nucleotide? It works by inhibiting an enzyme called dihydrofolate reductase, or DHFR. DHFR is responsible for recycling folate so that it can keep making T nucleotides. And researchers confirmed this in a clever way. They took cells and they treated them with EGCG. They noticed that the cells started dying. Then they added something called leucovorin, also known as folinic acid. Folinic acid is a naturally active form of folate that does not need your DHFR enzyme to work. The cells immediately recovered. This proved that the EGCG's damage was specifically caused by blocking DHFR. This is exactly how antifolate drugs like methotrexate work as well. They inhibit the DHFR enzyme. Now here's the ironic twist. Folic acid, the unnatural form of folate often found in prenatal vitamins, also slows down DHFR enzyme activity, and so it also reduces the production of T nucleotides. How does it do that? Folic acid is an unnatural form that your body cannot use directly. It is not biologically active. In order to become biologically active, it has to be converted into a usable form first. DHFR handles this conversion. DHFR converts folic acid first into dihydrofolate and then into tetrahydrofolate, which is the form that your body can actually start using. Without DHFR, folic acid is worthless. It just sits in your bloodstream as unmetabolized folic acid. And EGCG shuts this down so folic acid cannot convert into a more active form. So here's where the double whammy comes in. If you're taking folic acid, which already requires DHFR to become usable, and you're drinking green tea, which blocks DHFR, you created the worst possible combination. You're consuming a form of folate that your body has to work hard to activate, and then you're drinking something that shuts down the very enzyme responsible for that activation. For people who have already reduced DHFR function due to their genetics, and we'll talk about that in a minute, even modest inhibition from green tea can tip them into folate deficiency. This is mechanism number 2. One more to go. Chapter 4. Mechanism number 3. Destroying folate in your bloodstream. Here's the mechanism that catches most people off guard. Even after folate has been successfully absorbed and activated, EGCG can still destroy it. Here's how. EGCG generates hydrogen peroxide, a reactive oxygen species. This hydrogen peroxide directly attacks and degrades 5-methyltetrahydrofolate. That's the most active form of folate circulating in your bloodstream, the form your baby's brain needs. So let's recap what's happening here. Mechanism 1, EGCG blocks folate from getting absorbed in your gut. Mechanism 2, EGCG shuts down the enzyme that activates folic acid. Mechanism 3, EGCG generates hydrogen peroxide that destroys the active folates already in your blood. EGCG doesn't just prevent folate from getting in, it actively hunts down and destroys a folate that's already there. Now your body does have a defense. Vitamin C and glutathione can neutralize hydrogen peroxide, but when EGCG concentrations exceed your vitamin C levels or your glutathione levels, the protection fails. Heavy green tea or matcha drinkers can overwhelm their body's natural antioxidant defenses. This is why timing doesn't fully protect you. A lot of women ask me, can I just drink my green tea a few hours away from my prenatal vitamin? And the answer is, timing helps with mechanism number 1, the gut absorption blocking, but it does not help with mechanisms 2 and 3. Once EGCG is in your bloodstream, it's circulating systemically everywhere, and it's generating hydrogen peroxide everywhere. And that hydrogen peroxide destroys the folate you absorbed throughout the day. For high-risk groups, pregnancy, trying to conceive, breastfeeding, reducing your total EGCG intake is more protective than just playing around with timing. You need to reduce how much green tea you're actually drinking overall, or eliminate it entirely during these critical windows. Now, those three mechanisms apply to everyone, but there are certain populations where this becomes exponentially worse. Chapter 5, the perfect storm. Green tea's anti-folate effects matter for everyone, but they become especially dangerous when combined with common genetic variants that already compromise folate metabolism. There's a common deletion in the DHFR gene called the 19 base pair deletion. This genetic deletion reduces your ability to convert folic acid into active folate. In Japanese populations, 48% of these individuals carry 2 copies of this deletion. Nearly half of the Japanese population has compromised DHFR function just from their genetics alone. You already have an enzyme that's struggling. Now imagine combining that genetic vulnerability with daily green tea consumption. And then you drink something every single day that further inhibits whatever function remains. It's compounding. A pregnant woman with this genetic variant who drinks matcha daily and consumes folic acid is stacking 3 separate problems. 1, her DHFR enzyme is genetically compromised. 2, she's taking folic acid, which requires her compromised DHFR enzyme to activate folic acid. 3, she's drinking green tea, which blocks the same compromised enzyme. It's a perfect storm. And here's where it gets even more concerning. The MTHFR C677T, another folate gene variant, affects 30 to 70% of people worldwide depending on their ethnicity. If you already produce less active folate due to MTHFR variants and EGCG is simultaneously destroying the folate you do have, the compounding effect could be severe. Inadequate folate during brain development isn't just linked to neural tube defects. It's also a known risk factor for neurodevelopmental conditions and congenital heart defects. When you overlay 3 maps, high green tea consumption, high rates of the DHFR gene deletion, and high neurodevelopmental diagnosis rates, the convergence is hard to ignore. Japan has some of the highest green tea consumption in the world. They also have the highest rate of the DHFR deletion, and they report 1 in 55 children with autism spectrum disorder. South Korea shows an even more intense version of this. High green tea culture, significant DHFR polymorphisms, and a reported 1 in 38 ASD prevalence, one of the highest documented in a total population sample. The logic is simple. If your genetics already make it hard to use folate, and you're drinking a compound that further blocks that folate, you are effectively starving the developing baby of the most critical nutrient during its most sensitive window. I'm not saying green tea causes autism. Correlation is not causation, but the biological pathway is crystal clear. EGCG inhibits DHFR. DHFR is required for folic acid activation, and inadequate folate during neurodevelopment is a known risk factor. At the least, this convergence warrants a full investigation. I wrote a fully researched paper on this that I linked in the description below for you. So if you carry DHFR or the MTHFR variants, or both, which collectively affect up to 70% of the global population, green tea's effects, the negative effects, are amplified. This means that the problem is affecting hundreds of millions of people who have no idea. And this vulnerability doesn't end at birth. Breastfeeding mothers are the sole source of folate for their infants during the first 6 months of their life. If the mother's folate levels are depleted by EGCG, her breast milk delivers less folate to her baby during the exact window when the infant's brain is building its wiring. And here's another key point. After birth, the infant's gut produces PCFT, that folate transporter that we talked about earlier, at 15 times higher levels than most other tissues. That means the baby's intestines are desperately upregulating to pull every molecule of folate from mama's breast milk. And EGCG blocks that same transporter. Yet no studies have examined EGCG's impact on breast milk folate levels. So that is a very important unanswered question. Until that data exists, risk reduction is the rational approach. And here's how you reduce it. Chapter 6, the solution. I know this sounds scary, but it's important for you to understand it because medicine often looks at these pieces separately, and unfortunately it can take years for these integrated insights to reach the public. My mission is to help you connect the dots, and I want to leave you empowered, not scared. So if you're pregnant, trying to conceive, or breastfeeding, eliminate or at least drastically reduce green tea and matcha. Switch to safer alternatives. Rooibos is an ideal substitute. It's rich in antioxidants, there's no tannins, so it doesn't interfere with nutrient absorption such as iron, and it has a great flavor. and as an added bonus, it also has magnesium and calcium. Now, if you feel you need caffeine, perhaps you need additional B vitamins. Maybe you're low on iron. Maybe you need to eat more protein. Perhaps you're dehydrated and need more electrolytes. Dehydration is a very common cause of fatigue, and dehydration is very common during breastfeeding and pregnancy. I'll be sharing with you the cons of caffeine during pregnancy in a future video. Now, here's what you need to keep in mind. 1. Do not assume your prenatal vitamin cancels out green tea's effect, especially if your prenatal vitamin uses folic acid. The Boston University birth defects study found the highest risk in women who had both adequate folic acid and high EGCG consumption. The EGCG was undermining their supplementation. 2. Do not take EGCG supplements while pregnant. They are 10 times worse. They deliver 150 to 400 milligrams of EGCG per capsule, far more than any cup of tea. And 3, do not rely on timing alone. Timing helps with the folate gut absorption, but once EGCG is in your bloodstream, it's blocking DHFR and it's destroying your folate all throughout your body. Now here's the thing most women don't realize about folate. Folate is absolutely critical for your baby's brain and nervous system development, but the form of folate you take matters more than most doctors realize. Remember how I said folic acid is unnatural, that it has to be converted by the DHFR enzyme before your body can use it? Even without green tea blocking that enzyme, folic acid is still problematic because that conversion is catastrophically slow in most humans. Scientists tested folic acid on rats and approved it for humans because both species have the DHFR enzyme. But nobody checked if that same enzyme works at the same speed in both species. It took until 2009 when researchers discovered that human DHFR processes folic acid far slower, 98% slower, than rat DHFR enzyme does, which means that folic acid that we've been using for decades does not work nearly as well as we thought. So the folic acid in your bread, your cereal, and your prenatal vitamin, most of it just literally sits in your blood, unprocessed, blocking the real folate that your body needs. But there are 2 forms of folate that bypass DHFR entirely. These are methylfolate and folinic acid. These forms of folate do not need conversion. They go straight to work at their highest efficiency. Now, if you want to understand why folic acid is in our food supply, why it's problematic, or which of these 2 active forms of folate, methylfolate or folinic acid, do you specifically need, watch one of these videos next.